concepts. Most times, there's not one way to prove something, and this is a very important thing to remember for proofs. There isn't one way, so look for multiple ways to prove it if possible. And the second thing is that SSA is not a way to prove congruent triangles, and we'll talk about that more later. So we'll continue on. Reasons for statements. And what do I mean by that? So I'm going to draw a proof table, and we have reasons on the right and statements on the left. This is what you would usually see in a proof table. And if we have a statement as such, we have angle A is congruent to angle B. This is just an example, by the way. And we have to have a reason for it. That's the whole purpose of proofs, is to use reasoning to prove a statement. And we'll have usually have a statement on the left, and we'll have multiple different ways to prove it. And in this case, let's just pick vertical angles. So vertical angles would be the reason, and it's fine if you don't know this, but we'll talk about this more later. We have vertical angles is the reason why angle A and angle B is congruent. So that's what. And what are these reasons that we can list? Well, the first is given. So whatever the diagram or problem actually gives you is something that you can use in the reasons column. And the second is definitions. So the definition of a right triangle, for example, is also something that you can use in the reasons column. Properties of algebraic manipulations is also something that you can use in the reasons column, just like simple addition, subtraction, multiplication, and division is something that we're going to talk about as well later. Okay, theorems. There are a lot of theorems that you can use to prove such and such statements. And next is postulates. And postulates is just basically common sense, or just something that you can assume based on common knowledge. And that's also something that you can use in reasons. However, you want to be careful by not assuming things that are not given, that are not specifically given, and are not basic knowledge. So that's one that I would make sure that you'd be careful of. Okay, now we'll continue. So we have first addition slash subtraction property of equality. And this is pretty basic. Anything added slash subtracted to one side of the equal sign must be added slash subtracted to the other side as well. So if we have addition, we have if A is equal to B, then and C is equal to D, then A plus C is equal to B plus D. So we can see this as here. So if 5 is equal to 5, and 6 is equal to 6, then 5 plus 6 is equal to 5 plus 6. And we can replace the variables as well and see that works too. It's just common knowledge. A is equal to B. That means B is also equal to A. B can substitute in for A, and you can find that A plus C is equal to B plus D because they're just adding by the same thing on both sides. And this is just basically algebra. We also have the subtraction property. I won't go too in depth because it's basically the same thing as addition. And usually when you use this, you calculate the degree measure of angles. So the addition and subtraction property of equality will be used in a majority of the time just using to calculate angles. Okay, now we have multiplication slash division property of equality. And this is basically the same as addition and subtraction. So anything multiplied slash divided to one side of the equal sign must be multiplied slash divided to the other side as well. So multiplication, if we see here, if A is equal to B and C is equal to D, then A times C is equal to B times D. This is pretty self-explanatory. If we have 5 times 7, A and C right here, then we'll have 5 times 7 as well on the opposite side because they have to be equal. 35 has to be equal to 35. Okay, and then division, basically the same thing. And now we'll move on to the transitive property. If two things are equal to the same thing, then they have to be equal to each other. So as you see in the picture diagram below, we have to the side we have angle 1 is equal to or congruent to angle 4, and the reason why is because of vertical angles. And so we can write this to the side. Obviously, you can write this in a proof as well. So angle 1 is congruent to angle 4. And obviously, if I haven't mentioned this before, something being equal in geometric terms is just being congruent to something. Okay, so angle 1 is congruent to angle 4. The reason why, vertical angles. And we have angle 5 is also congruent to angle 4. And angle 1, because we'll just say angle 1 first. So angle 5 is congruent to angle 1. The reason why is because it's parallel lines and we have alternate interior. Angle 5 is congruent to angle 1 because of corresponding angles. And then we have angle 4 is equal to angle 5 because of alternate interior. And you'll learn this later, but what I wanted to say is basically, if angle 1 is congruent to angle 4, and then angle 5 is congruent to angle 1, that means without proving that angle 4 and angle 5 are congruent, we can already see that angle 4 and angle 5 are congruent. And not for alternate interior, but because of the transitive property. Because we see here, angle 1 is congruent to angle 4, angle 1 is also congruent to angle 5, and if angle 5 is congruent to angle 4, then we have then angle 4 is also congruent to angle 5. Okay. So now we're going on to the reflexive property. The reflexive property, I think, is one of the simpler properties, and the reason why is because it's just that something is always equal to and or congruent to itself. So what do I mean by this? So RT, as we see here, we see the line RT, and RT is obviously congruent to itself. And you might ask, why would you use this? Why will we use this? Well, the reason why is because if we're trying to prove these two triangles and we're trying to prove SSS, and we already have two of the sides, so we have RQ is congruent to RS, and then QT is congruent to TS. And the problem already states that they're congruent. We need one more side to use SSS as a reason, side as a reason, and we'll obviously use RT because RT is congruent to itself. So you can use that as an extra side and reflexive property as an extra reason. Okay, now we're going to move on to our final topic for today. And what can be congruent? What you might be asking. Okay, so lines, segments, angles, and shapes can all be congruent. And as you see here, for lines, we have line AB and line CD. They can be congruent. And the congruency symbol is just that. Just a small line through it, symbolizing that both of the lines are congruent. And if you have already two lines that are congruent and you want to add another two lines that are congruent, let's just say XY, PF. Okay, PF. If you want another two lines to be congruent, you can add double congruency lines to make sure that we distinguish that they're actually congruent. Okay. So segments can obviously be congruent. Angles can be congruent, as you see in this figure below. to the side, sorry, we have congruency angles, and we have congruency triangles as well. And for congruent triangles, we have congruent postulates. And as you see here, we have SSS, SAS, ASA, AAS. And what do all these mean? So SSS is side, 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 so three sides are congruent. SAS is side, angle, side, so side, angle, side. A side is congruent, angle is congruent, and another side is congruent. We have angle, side, angle, which is angle. One angle is congruent, another side is congruent, and then another angle. And then we have an angle is congruent, an angle is congruent, and the side is congruent. And why we have to follow this order? So we have triangle ABC. Triangle ABC is congruent to, we start at angle A and we see that there are two congruency lines. So we go to the next triangle that is congruent, and that triangle starts at angle D. And then we go to the next, we go to angle B, and that has one congruency line. So we go to angle E on the second triangle. And obviously we finish off with angle C is congruent to angle F. So when you're writing out congruency statements, you want to make sure that the angles are correspondent and congruent. Okay, so angle A is congruent to angle D, angle B is congruent to angle E, angle C is congruent to angle F, and those angles have to be congruent and in order respective to their congruencies.